Welcome to TechCrunch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation, merge, sort. Today we are going to present you a live demonstration and implementation of merge sorting using linked list in Java. Before we get into the implementation, let's first see and learn what is actually merge sort. In our computer science engineering, we process the data and that called data structure. And to process the data in a particular form like a searching or sorting, we named it as an algorithm. And these algorithm has a proper steps to perform and process the data. One of them is called merge sorting algorithm, where merge sorting algorithm is processed in 3 steps: divide, conquer, and merge. So let's take a look at one by one all these steps in detail. The algorithm can be described. So we divide. In these steps, we divide the input array into 2 halves and the pivot being the midpoint of the array. This step is carried out recursively for all the half arrays until there are no more half arrays to divide. So as you can see in this picture, what is happening, we have a set of elements and which is in the unsorted form. So as you can see in this example, we have some set of elements which is unsorted, and here we are going to divide it, and the recursively it processes to divide until we have the last and the only elements in the set. Now then what is happening? Conquering. So in this step we sort and merge the divided arrays. So we compare and we sort and merge the divided arrays and make it in a sorted subarrays. So that's what happening in the conquer step. So conceptually, merge sort works as follows in a recursive fashion. Divide the unsorted list into two sublists of about half the size and sort each of the 2 sublists. Now once the list is sorted, the sublists are sorted, then third step is what is called merge. Merge the 2 sorted sublists back into 1 sorted list. So this is the second step is done. Now we are going to merge these 2 sublists. This is the third step processing. Here we are comparing and merging 2 sublists and making 1 sorted list. Now when it comes to the complexity of merge sorting algorithm, worst case performance is like O(n) logarithmic n. So basically n is a number of elements and logarithmic means number of probability you have to process the data. If there are number of elements are more and you need to divide and recursively call the array, call the loop and perform the recursion until the list is single. So we need to compare and swap and sort and again divide and conquer and merge recursively. Calling this process will make it more difficult. So this is what the worst case performance. Now worst case space complexity, that means we are going to process it a number of times, and best case performance is like you already have the sorted and only you need to process once or twice based on the unsorted complexity. Average performance is O(n) logarithmic n. So now here in this session what we are going to do, we are going to have list of arrays in a linked list form. That means a linked list which is a linear data structure where each element is separate object. So you can see the linked list consists of nodes, and this node has 2 parts. One is data and another is address. Basically it's a reference variable, and the first element of the linked list is as head and the last is called tail, which is equals to null. So this is a singly linear linked list type of data structure where we are going to have the data in the unsorted form and we are going to perform the merge sorting algorithm in this type of data structure. So in short and in the generic form, if you see, the linked list elements are not stored at contiguous location. The elements are linked using pointers or reference variable. Each node of a list is made up of 2 items, the data and the reference to the next node. The last node has a reference to null and start of the list is head, as you can see here. So what we are going to do, we are going to have list of elements in a linked list data structure and which is unsorted, and we are going to perform merge sorting steps, divide, conquer and merge on this type of data structure. So this is what the implementation we are going to perform. You can see here we are going to have the recursive method. This type of sorting implementation can be done number of ways, but using recursion make it more efficient and best performance to be mentioned. So recursion here, what we are going to do, we are going to have a method which is basically self-called method. Within a method, we are going to call that method and make it in a repeated form. So this will make it more efficient. And so now the question is where we are going to use a recursion. We have seen that we have an unsorted list. We are going to divide into two parts and again divide into half and then again return the sorted array. And this is how we are going to sort it using the merge sorting algorithm, this unsorted array. Now, as you can see here, we have the odd number of elements. So what we can do, we still can do it in two parts, into half. One is greater than, it can be greater than, number of elements can be greater than other sublist. All we need to just make it in odd and even. That's it. There is no such difference. But we have to keep divide the list until it is only one. There are no other elements to be divided into or compared to. So this is what the process of merge sorting algorithm, and this is what we are going to do in an implementation using recursion. Now let's code on and see the live demonstration. So this is my Eclipse IDE and we are going to implement the merge sorting algorithm in linked list. So first thing first, we need to have the Java project. So let's get the Java project and merge sort algorithm demo. That's my project name. And in this project, let's have a source folder, and inside the source folder, let's open the package and the class. So in one step, I can create my package and class both. Merge sort linked list demo, and here I'm going to have my package. Package makes it more structured and organized code. Now inside, so we have seen the linked list implementation. What we need to have, we need to make the node. So let's start with node. I will have the node head my equals to null. That means my starter point. Now the question is, what is node? Let's make a class of it. Static class node. Now why I made it static? Because I don't want to make the changes once it is defined. That will make it static values. So its value exists until the method is implemented. Since we are going to use a recursion, so make sure our value is processed properly. So public node, and now this is my constructor where I have my argument mentioned. This will process it, and whatever you have entered in the value for the element will be included in this node. So once node is created, now next step we need to have the sorted merge method that has the argument return type of sorted merge method, argument and return type of node, because we are going to not just displaying the linked list and having a node linked list traversal, we are going to sort it. So we need to have the return types and arguments so that it will process properly and sort it out. So first we need to assume that the list is unsorted. So for that we need to have the result node, which is actually in a sorted, because we are going to divide it into and conquer. So we need to have the null value initialized, and if it is null, return b. That means there is no more element exist to your dividing. And not just that, we need to make sure we are returning the value. So this will keep divide the list, unsorted list. And since we have mentioned that linked list last element is equals to null, so as long as it is not null, it will keep sorting, it will keep dividing the unsorted list into two. Now what is happening here, I'm going to compare the value of the node, and if it is sorted, if it is in a ascending order, so that will return your result equals to A, and the result dot next equals to sorted merge A dot next, and another argument is B, so that will replace it and sort it. Now once this is done, this is your method, this is your if condition for sorting. Now here I'm calling the same method again until it is not sorted. So this is what the recursion called, self-called method. Now once this is done, else what will happen in the else condition, your result will be equals to B, because it is already assigned, the A is already set it up, sorted out. So result dot next equals, again I need to make a call of my self-called method sorted merge, and here the argument will be different because this is the different condition. You see, it is else condition, that means it is greater than equal to, the A is greater than equals to B. So once this is done, termination and closing the else condition, and then result has to be returned. Closing. So this is closing your sorted merge method. Now once the divide in sorted is done, next step we need to merge, the third step, that is called merging. We have three steps in merging: sort, divide, conquer and merge. So we have done the divide and conquer in the sorted merge method. Now in the next method we are going to do the merging. So for merging, what we have to do, let me give a different method name. It's called merging result instead of merge sort. Node argument is n, and instead of n, because if we have already used, let's make it h. Now in this method, what we are going to do, if in case your h is equals to null, or your h next, that means the next address of the node, next node is equals to null, that means it is the last element. In that case we need to return the h. And closing, the node of middle equals to get middle method, and we'll implement the get middle method. Basically, in case if you're merging, you need to compare the middle pivot, the average or the middle one, which we are taking a reference of it. So we are going to implement this method again. Let's first finish this concept. Your merging step, middle dot next. You see, so what is happening, we are taking a standard reference of the list, which is with the help of which we are going to compare and check the entire sorting, the merging the list. Because while merging we need to make sure we have to still again compare and see if it is sorted or not. And here we are going to call the merge sort algorithm, actually merging result. Self-called method h, and node we did for left. Now we need to process the same thing for the right side of the list, merging result method. And in this case we need to give the next of middle. And once this is done, the next step we need to have the sorted list, the result list which is sorted. Here we are going to call the sorted merge method, the one which we have mentioned before, implemented, where we have implemented the divide and conquer step. So once this is done, termination, return sorted list, the result list which is sorted. So this will return your sorted list, and termination, closing your method. Now out of all this, the another method what we need to implement here is called get middle. This is the important thing to know, middle node. So find out the middle of the node is basically another challenge for us, because that's what the reference, based on that what we are going to compare. So public static node get middle method return head fast equals to head. So there are two types of nodes, slow node or fast node, and that equals to head. While your fast dot next is not equals to null. So we need to select the middle value based on the speed of your comparison. If it is close to the value of your reference, what we are going to compare is equals to null, is not equals to null, then it is slow. And the slow means which is close to your right side or left side, like that we can decide it. And fast equals to fast dot next and return slow, termination, and closing the method definition. Rest, what next is left here, we need to print and push the data into the list. Since we are going to have the linked list and we already have the node, but we need to include the data value in the node. So for that we need a method called push, just like a stack we have, but in this case, since it's a linked list type of data structure, we need to have the new data value which is in an argument. And here node is the your static class object, and new node argument or the constructor will be your new data. Now once this is done, your new underscore node equals dot next equals head equals new node. Now this will push the data into the list using node in a linked list, and here we need to have one display which will print the list. Node head reference. Head reference will help you to make a reference of your start of the element, start element of the list, while your head pointer or reference null, and printing the value head reference dot value space head reference equals next. So this is what your implementation of linked list for pushing the data in a list and displaying it, and merging sort algorithm. Here we are using the middle value, and first we do the sorted merge method implementation, and then we have the merging result, which will process the third step, that is called your merging step, and in the end merging the unsorted list. Now let's go to the main method, and here what we are going to do, we are going to call the class and making an object of merge equals to constructor. That's it. It is what we can do using scanner input equals to new scanner standard input streaming. You can include the util package and make it simple, not complicated. What we are going to do, we are going to ask user enter number for list, and int a equals to your input dot next int, and here a. So you can have as first number, second number, what you can mention, and the first number and the second number. B, and here B. Third C. So this is my list of 5 elements. I'm just taking an example of 5 elements. You can have as many as you want, just for the sample and the demonstration. And once we have the list ready, you can print it if you want. Sorted linked list, unsorted list, linked list. And what you can do is merge dot your print display. Instead of head reference, you can have merge dot head. And next step, what we are going to do is merge dot head equals merge dot merge sort merging result, and merge dot head. Dot display merge dot head. So merge is the object of the class, and head is method. So 34, 12, 11, 67 and 43. Okay, we need a space now. So your values are 2 to 12, 67, 43. Now you see the way we entered it, it's taking it from there. So first value is 43, 67, 12, 22 and 23. And when it is sorting, so it is dividing into 2. So one is 3 and one is 2, and now it is keep dividing, and then it is sorted in the form 12, 22, 23, 43, 67. So this is the live implementation and demonstration of merging sort algorithm implementation in Java. When to use merge sort? An important fact to understand. Merge sort is used when the data structure doesn't support random access, since it works with pure sequential access forward iterators rather than random access iterators. So this is why we use only when we have some random access data structure to be processed. It's also widely used for external sorting, where random access can be very expensive compared to sequential access. Merge sort used when you need a stable sort. It is very important feature for merge sort. Stable sort means we have to make sure we have a reliable and more accurate instead of fast process of data structure. Merge sort is quicker when dealing with the linked list. This is because the pointers can easily be changed when merging lists. In Java, we have the reference variable that is called the pointers here. And that means because of the pointers and the references of the data node is easy to deal and make it more faster in case of merge sort algorithm. It only requires one pass for all algorithm n through the list. If there is a lot of parallelization occurs, then parallelizing merge sorter is simpler than other sort algorithm. So this is all about the merge sorting algorithm implementation in Java. For any kind of questions, assistance needed, please feel free to contact techranch2019@gmail.com. Please subscribe to our channel and stay tuned for more upcoming interesting, informative sessions based on Java application development. Let's make coding fun. Thank you.